Today we wanted to talk about how we use RTView in our particular organization. We're by no means the largest user or largest company using RTView, but we have kind of over the years it's kind of worked out to be a gamut of different use cases, and so I think it's kind of interesting to see how we're applying the product in those different ways. So a little bit about OOCL. We don't market to consumers, so you may not know who OOCL is. It stands for Orient Overseas Container Line. We're a public company based in Hong Kong. We were founded back in 1947, after World War II, with a single ship at the time. Now we operate 270 offices in 60 different countries, and we're part of a Grand Alliance that operates 120 ships in total. We have about 700,000 TEU containers or container fleet. TEU is a 20-foot equivalent unit, so that's the 20-foot and 40-foot. Our revenue is around $6 billion a year, something like that. And we're considered a leader in information technology in our particular industry, the ocean container carrier industry. We've been using TIBCO products for the last 6 years. And in particular, we have EMS, Business Works, Business Events, the B2B products, Spotfire, RTView, and I forgot one that our CIO actually spoke at the last year's TIBCO, which is TIBCO. We're one of the first sites to start using that. So one thing that makes us a little bit different in our particular industry. So American Shipper Magazine, this is from a recent July issue, had a cover story called Seasick Industry, about the ocean container industry and the poor shape that it's in as far as financial performance and long-term viability of a lot of the carriers. OOCL was one of only 2 carriers named in the article that we've had a profit in 2011. So that was out of a list of about 30 carriers. And in total, OOCL's had the largest profit over the past 5 years combined of any other carrier. And that includes carriers such as Maersk, which is 6 times our size. They have about 25% of the market share. They actually have an oil company subsidiary, so that in a way they can kind of cheat when oil costs are high and so on. They have that extra advantage that no other carrier has. Even taking all that into account, we've outperformed them in terms of real profit. So in the article, they had a quote from one of the industry consultants. So over that 5-year stretch, one line stands out. OOCL made at least double the profits of every other publicly traded carrier except for Maersk, which grew just a little bit more profitable than they are. OOCL has consistently outperformed the pack despite the relatively modest scale. Good management remains key. And so that's one of the points that I wanted to really kind of drive home. How this ties into that concept of good management and how we can differentiate ourselves in a highly commoditized industry and achieve those kind of profitable performance. So good management, so a large part of that is being able to see what's going on now. Not what happened 6 months ago or a month ago. And we heard that over and over at this conference. And really having the ability to, what I would say, separate the wheat from the chaff. From all the data that you have, what's the really important context, and being able to identify what does this mean, what action should be taken because of it. So you need to have the right people who are working on a particular problem at the right time and with that right contextual information, right? So that's what you want to do. And we need to also understand the consequences of not doing this correctly. So according to some standard averages for our industry, every minute that we have downtime costs us $10,000. So that's a lot of pressure when you get the call at 2 in the morning and you need to respond quickly. By far, our biggest cost, approximately 30% of our cost is fuel. We use the low-grade bunker fuel. It's actually a solid, so it's a lot cheaper than what you put in your car. But still, those fuel costs are really eat into our margins and so on. And so if we have a delay leading port because we have the system down, we can't deliver the manifest, so we can release, we can't do the customs clearance and so on, then the ship is sitting there waiting to go, and we have to speed up to hit the berthing window at the next port, and when we have to speed up, that costs us, that's additional fuel costs, and information and letting them know what's going on, giving them the truth, then they're going to pay a little bit more for the services that we provide as a result of that. And so that's a really key differentiator for us. So all this ties together. So when we look at our monitoring solutions and what we try to do with RTView, one really key thing for us is development productivity and time to market. We can never get these solutions into the hands of business users fast enough. I'm sure all of you have a lot of those same challenges. So how do we make our developers more and more productive? How do we do more with less time, less effort? And so RTView has a lot of features and capabilities that really address that directly. And that's one of the reasons that we really like that product and have used it so heavily. We need an effective platform that helps us gather and aggregate and display that real-time information, regardless of lots of different sources. We want to reuse components that we create, different visualizations and so on of that real-time data wherever we can to help us with that productivity. We want to use the data sources that are already there and avoid having to do transformations and conversion of data into a form that the tool can accept. And we want to capture information exactly one time if we can, and then reuse that and correlate that and apply it wherever we need to. And as we mentioned, it's really important to have the information displayed in context. And this is another area where we've really differentiated the monitoring solutions that we build versus things that we can create in other tools that we also use. It's that contextual aspect that's really missing. So you can see displays of how a JVM is doing, but you don't really know what applications are displayed on that JVM, what it means as far as the business impact if that's not performing well. And so you need to have a way to be able to do that for this to be effective. So does the server pose a critical business application as a part of a fault-tolerant configuration? And so my response is going to be different if so. Are there other servers that are sharing the same platform resource that are also having a problem? And that allows me to triage or assign a different team to respond to that based on that additional information. So those are ways that context really helps you diagnose, troubleshoot, and get the right people working on the problem as quickly as you can. So another challenge that we have in addition to the development productivity is the complexity of our systems are increased. They've increased really dramatically. So our legacy ERP system is actually based on a small pot. It's architecturally very simple, a client-server type of thing. And now we're moving into event-driven architecture, and there are many, many more components, many more interactions between those components. And our operational teams, they say, why can't it be, simple like it was, in the old system where we only had a couple of components we had to deal with. Well, that's the price we're paying for more real-time, reduced latency, being able to do more with these events. The price that we pay is more complexity in the architectural components we have to deal with. So we have to have a way to effectively monitor and manage and control those. One other side benefit, though, is that that's allowed us to reduce the tight coupling and allow us to decompose our systems to improve our agility. But that's a byproduct. So it's definitely worth doing, but there's a price there. The constant drive to reduce information latency, so it's hard to have a 2-second advantage if your data is 2 hours old. And support access to aggregated data, updated projections, and our analytics results. And have it available in our transactional systems at the point that the person is making a decision. So that means real-time access, real-time response times to aggregated data, and that's a whole different kind of challenge. So I wanted to walk through several examples. This is not a comprehensive list of how we're using RTView, but representative samples that kind of show different components in the way that we interact with our RTView team as well. So these are what we call central monitoring and control, which was a custom application, monitoring application we built entirely in RTView. We use some standard components, the Oracle coherence monitoring, and business events monitoring that we collaborated with the RTView team to create that, because there really wasn't, and still wasn't quite yet, this kind of a tool for business events. And then actually moving into, from monitoring our systems to actually monitoring our business, and an example of that. So we kind of start for our central monitoring and control is at the highest level, and this is applicable to something that Ted will talk about at the end when we're trying to look at the next things that we want to do. But we can have like a health summary that shows the platforms and frameworks we have, the applications, and it's very simple. Green and red indicator is that component healthy or not. So you can see it at the highest level. So this is something that's on a flat panel display in the operations center in Hong Kong, and so people can see that 24/7. And if something turns red, then they know they need to go look at something. So that's as simple as we can really make that. But now I need to figure out why is that down, what's the impact of it. So now we can have a drill down from any of those particular squares to go down to the end-to-end application data flow. So this shows some components. So we have a laser pointer here, so I can focus on that. We have some external components that this particular piece depends on. And so those are shown as squares. We have GMS destinations that are shown. And so each one of those destinations has the name, the number of messages that are in the associated exception queue. So for some reason we couldn't process a message, we moved it to the corresponding exception queue, so now I can look at the size of that. How many messages are in the normal queue, how many consumers I have against that destination, the message processing rate that I most recently measured, and how much time it's been since the last time I processed a message. Okay. So those metrics now we get for any GMS destination. We created this component in RTView, and now we can reuse that over and over again. All we need to do is give the destination name, and now everything else that we get for free from them. So that's what increases our productivity. For each one of those metrics, we can also define an alert. So we can have a threshold depending on the environment, whether that should be shown as yellow, which in our case means that we're not meeting our SLA, or it can show as red, meaning that within a response time window, we expect that we're going to have a production stability issue. So if it's red, that means you need to call somebody at 2 in the morning to kind of. And those thresholds can be set, it's all configurable through a page in the application, so they can change based on the requirements and things. They can modify those. And we can see up in the upper right-hand corner, we have a case where the exception queue has more messages than we expect to have in that, so somebody needs to respond to it. Now, the other icons that we show here, in this case, these are business works processes. We also have icons for business events, inference agents, and cache nodes, and for WebLogic server or the older the J2E containers, basically, that we also monitor. And so now I can see from this, if something's red, I can understand the impact on the end-to-end flow for that particular component in detail, and I can get an idea of what the business impact of that is, which users are impacted, which business processes are impacted, and so now I can actually inform the business end users what's going on. I can get the right team working on it, because now I know. I don't have to hunt through a whole bunch of log files to try to find out where the problem is. Now I know exactly which team needs to respond to it. Okay? And so this is actually then painted. Usually we have components that we've developed with a regular Java developer, basically learned RTView and implemented this. Once we've created the components, our server technology team, who aren't programmers, now can create these displays. So whenever we roll out new applications, we provide the architectural flow diagram, and then the alert threshold, and they actually create and maintain this display. So now I can further drill down into one of those JMS destinations, and now I can get even more detailed information about Spark chart showing a period of time, what the message processing rate was, whether I'm catching up to the backlog or there's still some problem. I can even see the different listers on the J2E containers to see if I have a slowdown that's affecting just one particular host, if it's reacting a little differently than the others, and so on. And that drill down for this display is also, we also find that one time, and this is all reusable. So again, just from putting the name on the top level, signing that component, I get this drill down for free as well. And then finally, we have some custom built monitoring that we've done at the platform level, in this case for EMS, that really shows some of the key metrics that we want to have. The RTView team has a packaged EMS monitoring solution as well. In this case, we created one that was what we wanted in that particular case. So we can monitor the health of this and the active passive availability, what the uptime has been, and so on, just general metrics about that platform piece. So that's our custom created central monitor control. We have, I think, about 60 displays that are part of that. We also use some of the RTV team supplied packaged solutions. So in particular, we use Oracle Coherence for distributed caching. And your choice is basically to use the Oracle Enterprise Manager, which has been, I attend a lot of the Oracle Coherence special interest group meetings in the Bay Area. It doesn't provide the kind of information you need to make sure that your coherence cluster is stable, working correctly, and to troubleshoot issues and so on. So we've actually deployed this particular solution, which gives you a really rich view of what's really happening in your cluster. And I think this highlights one of the things about the RTView team. It's not only their expertise in using in RTView in the product, but it's also their expertise in working with real-time information displays. They invested a lot of time in understanding in coherence, what are the MBs that you really need to look at? What are the ones that are significant? What do they mean? And that's a lot of the value in this solution is really from that expertise, that research that they've done, and compiling it together. So we didn't have to go and do all that on our own. We could just take that and plug it in. So now anywhere where we have, in our central monitor control, we have a problem that we detect in the coherence cluster, we can now drill into this and then see what's happening in more detail with that platform-specific view. I have a couple of screenshots for this. This is kind of the overview showing what's happening for the whole cluster, how many nodes have been up, whether I'm basically node safe or machine safe. So in other words, if I have if the machine fails, am I okay? Am I going to lose any data in my cluster, and so on? So it gives you that kind of summary if everything's okay there. And then kind of overall statistics on the health of the cluster. And then I can go into more detail into a single cache and look at my hit ratios over time. It's kind of a time series. I can look at how many objects I've actually got in the cache, how many are being evicted, do I have to add more memory, those kinds of things. So I get displays that are at that level. And from the drop down at the top, I can then select any of the caches that we have in that cluster. And these displays work for both the back-end and front-end aspect. So if it's our application that's joining the cluster, it's not a storage node, but it's using it, I can still get metrics that show how that's interacting with the rest of the cluster. So it's a very, very sophisticated display, very useful, and our team really likes it a lot. Okay, then we use a lot of TIBCO business events in our application. We'll touch on some of that in a little while, but we really didn't have a good solution for monitoring in detail what's happening in the business event platform. Typically what would happen, one of our senior engineers who really understood business events would use JConsole. He would go and connect to the right server, go server by server, inference agent, looking at, hunting through the outlines and finding the MBs that he really was interested in, to troubleshoot a particular problem. And it's a very time-consuming process. And remember, we're $10,000 per minute, right? So it isn't long before that becomes a real issue. And you have to really, and anybody who doesn't really understand business events, it's not going to be able to help them too much. So we can't really provide alerts on JConsole that are going to be meaningful to somebody else. So we started working with the RTView team earlier this year and brought in one of their team members to help us combine the expertise of our senior engineer, what does he really look at, what are the MBs that he pays attention to, and so on, and then try to craft a display solution that's similar to like the Oracle Coherence Manager. You see that has a similar look and feel, and I don't think that's accidental. And so here we can actually show information about a particular inference agent. What are the RTC cycle times? How much is it spending time in the vacuum store doing updates? What's the size of the, we use the cache aside approach. So what's the size of the compute for updating the cache? What's the size of the cache? What's the hit ratio that we're seeing there? Again, we're on the version 4 business events that's still using coherence, and so we could use the OOCL to look at the coherence aspect of that if we wanted to understand the cache behavior there. And so this allows us to really troubleshoot and assess the healthiness of the business events parts of the application. So these are the inference agents, and then we also have information on the cache nodes, as I mentioned. So this is specific to business events. It's a little different metrics than what the OOCL solution is showing. But in this case, we can see basically what's the time for doing puts and gets related to the concepts that we're updating and putting into the cache. We can also look at things through a event view, through the channels. What's the processing rate we have through those channels? What's the backlog that we have? How fast are we doing gets and puts for the locking and so on and processing events through that channel? So it's really the whole comprehensive view of the business events application, seeing all aspects of that. And then this is another view of the channel where we're looking at the number of events that we've actually processed over time and whether we actually have a control here. So if we want to suspend the processing of events from a channel, we can do that with the view and halt it for a period of time, depending on if there's something that we need to do to troubleshoot or throttle or deploy something. Okay, then the last sort of monitoring that we use in the RTView product for is really related to monitoring our business itself. So this is an entirely different usage. Users before, for the other views we've seen, are typically the folks in the data center, the folks in the application support, the server administration folks. They're the ones that are using that. This is something that we're actually exposing to our end users to help them understand what's happening in the business. So this is a whole different thing. We can have if we have issues inside our IT department, that's one thing. If we have issues with your end users, that's a whole other thing. So that's a whole other level of trust that we have on the platform. And in terms of the scale, the number of users that we have, the amount of data that we're actually collecting and displaying. So a little bit of explanation is needed, I think, for this display, which is kind of called the bubble view. I don't know where that name came from. In our shipment life cycle, we have a series of what we call checkpoints. So, for example, one of the early checkpoints is to have an empty container go out to our customer's premises. And so until that happens, nothing else can come after that. So for each of these checkpoints, we can define dependencies that tell us which things need to be done before something else can proceed. And then each one of these checkpoints is associated with a workflow. So the workflow could be automated, it could be manual. And so this is the way that we can decompose our complicated end-to-end business process into manageable pieces. If we try to implement the entire end-to-end flow as one component, it's just too complicated, too fragile, constantly changing it, difficult to customize and so on. So this is the strategy we use to decompose it. Each of those checkpoints then has a state for a particular container. So it could be dependent, meaning that some prior step hasn't been completed, so we can't start this yet. It could be pending, meaning that we've started it and we're waiting for it to be done. It could be completed, or it could be not applicable, so that's one that doesn't apply. So the case that we talked about, an empty container going to a customer premises, if it's a shipper-owned container, in other words, the customer is providing the container, we don't expect to have to send one out to them, for example. And so we actually have a business events layer that models these checkpoints, that has the rules for telling us whether this applies or not, whether it's been completed, whether the dependencies have been cleared, and so on. And then we'll get subsequent events when these checkpoints change state. The events are then used to fire off workflows and kick off the automated processes of the human tasks. So one of the challenges that we have is that we want to do a lot more automation see what's really happening. Is the system really working? Is it doing what they expect? Or are they going to get calls from customers telling them that the system's not handling it? So that visibility is really crucial to getting the acceptance to the automation. And so that's one of the reasons that this was an important component to put on. So this view shows, I can, for example, select a particular facility, and I'm looking then at all, in this case there's 357 containers that have started the inbound process that are in the corner being delivered to customers, and that are going to go through this New York City 03 facility in this case. And then this shows me the status of those 357 containers. So which ones have cleared, how many have cleared each checkpoint, and so we just have a pie chart that shows that information. And you can look at this based on the voyage that it was discharged on, or however you want to manage that. And then someone who's responsible for making sure that this process is fulfilled can look at that to understand the problem. Do they have a problem? Are things flowing smoothly? Do they see the status that they really expect? And then if you click on one of those little pie wedges, you can now drill down. So in this case, we've clicked down, and now I'm only looking at, in this case, these are the ones where the cargo release checkpoint is in a pending status. So I wanted to see, okay, what are all the ones that are ready to go, they're not yet completed. I want to drill down and look at those and understand better what's happening there. So now I'm just seeing the view based on that filtering. And then I can choose to go into the details and see the details of those shipments that apply to that filtering. And so they, I don't know if your end users are like ours, but for them everything's a spreadsheet. They all upload spreadsheets and grids of data, and then they can export it and do things that they want with it. So we can actually do that with this. We actually have 100 different columns that we show. And then the ones in blue indicate there's some human level tasks that's waiting to be completed. So now we have a status at the bottom that shows what is the status of that human task, who's assigned the task, what's the status of it, and so on. So we can follow up with somebody, we know who's responsible for completing that. So, it kind of gives you a range of different things from creating our own solutions with RTView for both our business end users and our operational monitoring for our systems. And then also some of the package solutions that we can just plug in and really build on the expertise from the RTView team in doing that and giving us a more productive solution. So what are the next steps? What are the things that we want to do beyond this in our solution? So one is we want to capture the component dependency model more fully. So if we can tell that this particular BusinessWorks process depends on these other components, maybe it's on this EMS server and another database, and maybe it's calling a web service synchronously for some WebLogic server. If we can understand those dependencies in a model, then we can enable things like automated start-stop. So we can start and stop things in appropriate order and make sure that we don't have issues there. Remember, we have a really, really complicated environment now. So the operations folks, their default is stop everything, start everything, right? And it takes a fair amount of time to do that, again, $10,000 a minute. So we want to only start or stop the components that we really need to do. That requires that we have that kind of understanding. And then also for alert consolidation. So we have that health summary where at the very top we have red or green. And so the challenge there is that if I have any underlying component that's red, then by default the health summary at the top has to be red. Well, maybe I've already looked at that problem. We're going to have a solution for that soon, so we're not too worried about that. Well, then that means that somebody's ignoring the top level alert. So now if I get another alert that's unrelated to the first one, everything still shows red, and I've got the Web-Private Wolf kind of syndrome. So if we really understand this dependency, now we can do something a lot more sophisticated in how we correlate alerts, how we consolidate them, and do it in a way that doesn't disguise important information, but still make things manageable and not bombard the operational team with thousands and thousands of alerts that they don't really know what they need to do next. So there turns out there's a solution for this that the RTView team put in where we just learned about recently. Beach is our biggest terminal. It's one of the biggest in the world. And obviously a huge amount of our percentage volume into the U.S. West Coast goes through Long Beach. So we signed an agreement, a 40-year lease with the Port of Long Beach, and we're making the biggest investment we've ever made in our company's history to build out a terminal facility that will be able to handle 3 ships simultaneously when it's completed in 2017. And it's going to be completely automated, so a completely sealed environment. The gantry cranes, that load and unload from the ship, the straddle cranes, the bomb carts, everything will be completely automated, and so the whole facility will be operated by about 20 people, 3 ships simultaneously, 20 people. It's quite amazing, yeah. Now, talk about monitoring, and being able to see what's going on, be able to be proactive, it becomes even more critical because you don't have the ability, if somebody has to enter the facility, you have to stop everything for safety reasons and so on. So this kind of monitoring is going to be really key, and so the team responsible for that is also talking to the RTD folks to give that kind of visibility into the facility. That's an exciting project. One of the things we wanted to highlight is what is it like to work with the RTD team? We already talked about being highly productive in terms of our development. That's something that we really needed to do, and we really see that with the product. And we've seen some of the things we can do as far as the reuse, allowing people who aren't developers to be able to create solutions with it. And there's a wide range of platform solutions that we can already plug in. We didn't mention that there's JVM Monitor, there's BusinessWorks, and so on. So a lot of components that can be plugged in directly. And it's really a full-featured platform for transforming, aggregating very powerful cache manipulation utilities. You can create your own functions to manipulate the data, so we really haven't touched on a lot of those capabilities. Strong alert management, as we mentioned, and scalable and efficient. When we moved into the business user aspects of it, we had to be able to scale the solution out. Built on standards and able to natively collect information from our commonly needed sources, from JMS, as we saw, a database from JMX, log files, Hawk agents,